Hi, in the last few sessions, we talked about the VHDL process blocks and we made some basic understanding of it. Now, in this session, we will discussing some of the examples and we will talk about some good practices while you are using those process blocks. Okay, so let's start. Okay, so this is our example 1. Now look at this example. Here we have two process blocks. First is process 1 and second is process 2. As we already talked about this and we already knows that all the process blocks within the architecture body executes concurrently. So this means that both of these processes will execute together at the same time. There is no problem in this, but look over the assignments inside these process blocks. Both of these process blocks are assigning the data into the same output signal, which is Dout. So process 1 is saying that Dout gets a value of A and process 2 says that Dout is B. And now there is a problem because they both execute at the same time. And suppose signal A value is 0 and signal B value is 1. Then what will be your output signal Dout when both the assignments run at the same time? Note that both the assignments running at the same time because these two statements written in the separate process blocks which are executing concurrently. Now you may say that the execution of process blocks will only happen when the signals in the sensitivity list changes. So if A changes, then the Dout will get the value of signal A, and when B changes, then the process 2 will execute and the Dout will get the value of signal B. Let me know from the comment section if you are also thinking the same. If yes, then here is the question. So what will happen if input A and input B changes at the same time? This means both the processes will execute now at the same time. And now what will be the output Dout? Confused, right? Well, this is the reason that this type of codes are not allowed in VHDL. This means that the output signal must be driven by the one assignment only. Either you are using it inside the process block or even if you are doing the assignment directly inside the architecture body. Now, if you understand this, then I have another scenario for you in the next slide. Okay, so look at this example now. Here I have removed the second process block and I have written the statement of that second process inside the process 1. So in the last slide, Dout was getting the value of signal B, right? Now this statement is here in the process 1. So now the code is process 1 colon process A comma B begin Dout gets the value of A semicolon, then Dout gets the value of B semicolon and process semicolon. So in brief, here we have the scenario when we have the two assignments on the same output, but they are inside the same process block. Now my first question is that allowed? So the answer is yes, definitely this is allowed by the VHDL compiler. Reason is that there is no conflict in the assignment of output because these two statements inside the process blocks will be executing sequentially. Means first the statement 1 will execute and then the statement 2 will execute. But this is the problem itself. Well, this is not the syntax error or the compiler error, but this is the logical error. And the VHDL compiler will not tell you about this functional error. Can you guess that what is this functional error here? Well, here the problem is that the first statement, which is Dout is A, has of no use because Dout signal will always overwritten by the second statement, which is Dout is B. Means whatever the value of A, you will always see signal B data in the output because first the data of signal A will move to the Dout and then the data of signal B will move to the Dout. And output signal will be overwritten with the B signal. Now, if this is clear, let me tell you what is the good practices then when you are working with multiple process blocks in your designs. Now look at this example here. So this has two process blocks. Process 1 is here. Process 1 colon process A begin Dout gets the value of A and process. So in this process, we have signal A and we are assigning signal A data into Dout1. So this is the one output of our design. Now process 2, so it is process 2, process B begin Dout2 gets a value of B semicolon and process. Means this process block using another signal B and its data is being assigned into the another signal Dout. This is our second output. Means there is no overlapping on the output signals here, and there is no conflict as well. Well, you can also write these two assignments in one signal process block. Now look over this example. Process 1 colon process A comma B begin Dout1 gets the value of A semicolon, Dout2 gets the value of B semicolon, and process semicolon. So when this process block will execute, at the first statement signal A will be assigned to Dout1, and at second statement signal B will be assigned to the Dout2. Means you will be getting the same results what you are getting in the last slide. Okay, so that's it for today. I hope you have a clear view of the process blocks in VHDL. But before we conclude, here is a quick recall on the sensitivity list, because this is one of the most important factor of the process block. So for the combinational processes, you need to include all the signals in your sensitivity list, which are being used inside the process block. Note that the sensitivity list cannot be empty. It is not allowed in the synthesis. If you are designing registered process, then you should include clock signal and reset signal in the sensitivity list. Now you should remember that the VHDL compiler will not give you any error if you are adding more signals in the sensitivity list. Either you are writing the combinational process or you are writing the registered process. But you will see the differences in your simulation results and in your synthesis results, because the output may not function correctly, or the output you are getting may not be expected from your design. And this will happen if you are not following the good practices with the sensitivity list when you are working with the VHDL process blocks. Although there are some situations when you can leave your sensitivity list blank. However, there are some conditions to that. Like the first condition is that such process blocks can only be used for the simulation purposes only. You can use them for the test functions only. Such process blocks must have the wait statements inside, which will be alternative to the sensitivity list, which tells your compiler that when the process block should run. But the most important keynote is that such VHDL codes which has the process blocks without the sensitivity list, these are not synthesizable. This means that you cannot implement them into the hardware or FPGA. In the next session, we will be talking about one of the widely used conditional feature in VHDL, and that is if-else. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.